In this video, we're going to simulate the flipping of a fair coin. So we're going to write a formula to simulate a random flip of a coin. We're going to flip it 10 times and we're going to see what the average result was. We'd expect that to be close to 50%, but probably not exactly 50%. The first thing we need to do is generate a random number. And Excel lets you do that using the rand function. It doesn't require any parameters in the parentheses. Just rand with some closed parentheses and you get a random number between 0 and 1. It could be equal to 0, but it's going to be less than 1. And from there, we can round that number to 0 or 1. So we'll use round with 0 decimal places. And if it rounds up to 1, we'll call it heads. If it rounds down to 0, we'll call it tails. Now, every time the spreadsheet recalculates, we'll get a new flip of the coin. And we can recalculate the spreadsheet by typing something in, typing in text or a formula. And notice every time I hit return, the random number changes and likely the heads or tails outcome will change. Other ways we can cause the spreadsheet to recalculate is just to hit the F9 key. Hit F9 and we get a new number. Hit F9 and we get a new number. So let's try that 10 times and record our results and see what the average is. You can type in the 0 for tails, and when I hit enter, it automatically recalculates, so I can hit a 1. And it automatically recalculates, and I'll just type in what I see each time. What are the chances of us getting 5 heads in a row? Might skew our average a little bit. Yeah, we got an average of 70% on that simulation. You can imagine if we were trying to do a lot of realizations in our simulation, say 100, it would get really old typing them in. So on the next sheet, we'll talk about a way to speed that up. But before I leave, let me go ahead and display the formulas that we used here so that you can see them in the video. Hit pause if you need to. And when we move to the next sheet, we're going to take advantage of this fact that we really could have put these two cells in the same formula. We could have, instead of rounding cell B15, we could have just rounded the rand function, combine these into one cell. So let's do that. Let's take our formula and say round rand 0, and that will again generate a random number from 0 to 1 and round it to 0 decimal places, which will give us either a 0 or a 1. 1 for heads, 0 for tails. And let's talk about what kind of outcomes we might expect. We expect heads to be 50% and tails to be 50%. We're going to do a simulation and see what the actual outcome is, and then we'll draw a chart to compare the two. So we're going to use data tables here, and if you're not familiar with data tables, I would jump out and look at this video, or you could just follow along and I think you'll catch on pretty quickly. So we'd like to do a certain number of realizations, and for each one we want to capture a result, and we're going to use a data table to do that. And so I want to do 25 realizations in this Monte Carlo simulation. So I'm going to count off 25, and for each one of those realizations I want to grab the result over here. If you looked at my video, you know that I like to color that cell yellow because it indicates where the data table is going to look for an output, and I like to color these cells blue because that reminds me of which cells in the data table Excel is going to come along one at a time and plug into some input to a formula. Now clearly our model, input to a model. Our model doesn't have an input because it's based on a random number which we don't need to input. But in order to make the data table recalculate the spreadsheet 25 times and then record the results of the coin flip for each recalculation, we need to plug these numbers in somewhere. We could plug them in here or here or here or here. Better not plug them in there because that's going to interfere with our model. But really, that cell and these colored cells are the only places on the spreadsheet we shouldn't plug them in. For the purposes of this video series, I'm going to use this cell because in a 1D data table, it's never used. So let's go ahead and build our data table by highlighting the colored cells, going to Data, What If Analysis, and Data Table. And let's tell Excel that we'd like it to one at a time go through this column of cells and take each one at a time and place it in this column input cell M2, which is going to have absolutely no effect other than to make the spreadsheet recalculate. And each time it does that, it will grab this value and place it in the table. So when we hit OK, we get 25 random coin flips. We could average those just by highlighting them and looking down here at the average. So 48% of those coin flips were heads, 52 were tails. I could calculate the average. Watch what happens. I better put that over here. When I calculate the average and hit enter, what's going to happen? The spreadsheet's going to recalculate, and all of these are going to recalculate. So if I hit enter, all those numbers changed, and this time in our Monte Carlo simulation, 40% of the realizations were heads. And when I hit enter for that cell and it recalculated again, 56% were heads. So we can hit F9 multiple times, and each time we hit F9, the spreadsheet's recalculating. We are running a Monte Carlo simulation with 25 realizations and looking at the mean of the output. We could also measure the standard deviation of the output if we cared. And so if I'd said the actual number of heads in that realization, I could point it right at that cell. And the actual number of tails would be 1 minus that amount. So let's just compare that in a chart. Let's select this data and say Insert Column Chart. And we got rows instead of columns, so I'm going to go select Data, switch those. That looks a little more like what we were hoping for. Let's call it Simulation Results. And where we expected 50-50 heads and tails in the blue, what we actually saw in these 25 realizations was more like 64% heads, 36% tails. So let's just watch that chart and see what happens as we run multiple simulations. So I'll hit F9. That time we've got a lot more tails. F9. And that time we got a few more heads. Actually, let's start a new sheet and let's see how many realizations it would take to get these numbers to tend to be closer than 50%. I'm going to copy this sheet. Rename it as 3. Get rid of our chart. So I'm going to get rid of our average. And let's create a new simulation with 250 realizations. So to clear out a data table, we first need to come in here and delete this array of data. I know it's an array because when I click on it, it's got some squiggly brackets there. So we'll hit delete. And let's just extend the column of data down to about 250. Go back, rebuild our data table by selecting it all. Doing a data, what if data table. And this time we'll plug those cells one at a time, those values one at a time into this cell. Say OK. And we got a whole new simulation. Looks like we left one of our cells formatted the wrong way. And every time I hit F9 again, I get a new simulation. So let's take the average. %. And every time I hit F9, we get a new simulation. And we appear to be within a few percent of the 50%. That's a whole lot closer than we'd seen last time. And that's because we're flipping the coin 250 times. Would expect to get something closer to the average. I think they call that the law of large numbers. But let's see how many it would take. Let's do something here and say, what's the average? Let's calculate a cumulative average. And if I lock the first cell with F4 and hit enter, and then I copy that down, I'll have a formula that calculates kind of a cumulative average of everything above it. For example, if I come in here and hit F2, I see I'm taking the average from the first iteration through the 13th. I come in here and hit F2, I'll see I'm taking the average from the first iteration through the 22nd. So we would expect the first number to either be 100% heads or 100% tails. And let's go ahead and format these as percentages. And then the next number might be 100% heads, 100% tails, or 50% of each. But as we go further and further down the line, we'd hope that we converge on the 50% number. So let's select these results, go back to the top, and let's insert a chart that looks like this. In fact, let's go ahead and add some X numbers on there. X values to show what iteration we were on. And so after the first iteration, again, we were 100% heads. After maybe about 10 iterations, we were about 60% heads. And after 240, 250 iterations, looks like we were about 44% heads. That's what it says up here. Let's hit F9 and run another simulation. This time, the running average converged on 47%, which is better. Let's hit an F9 and do another simulation. This time, the running average converged on 46%. That's a little hard to look at with this jumping around. I'm going to fix that axis to go from 0 to 1. And then I can hit F9 a few times and just kind of see visually, are we converging to that 50% with each of these? And we're getting close. It looks to me, just by inspection, that after about 100 iterations, we're pretty much going to converge close to an answer. So if I were doing a Monte Carlo simulation here, I would not want to trust a model with 10 iterations. I probably wouldn't want to bother building a model with 1,000 iterations. Probably somewhere in this 100 is going to be close. We could dive off into the weeds and talk about sampling distributions and why that's important, but I think that this is probably sufficient to get the point across. And let's just call this convergence. So let's review. We have learned how to flip a coin and record the results to get the average of 10 coin flips. We learned how to make that a little bit quicker with a data table. Still measure the average and look at how that average compared to what we would have expected. And then we've also learned how to look at the running average of the simulation as it occurs to see how quickly it converges to an answer. In the next set of videos, we're going to play with some dice.